Welcome to this lecture about suspensory ligament injury in the dressage horse and muscle training, and I'll show you those two have something in common. When we talk about muscle development, one of the questions we could have is how do you build muscles? And another question, nearly as important, is can you overdo it? Well, this lecture will give you a clear answer on those two questions. Muscles are cells that can contract and relax. A lot of those cells are sleeping, dormant, and when you really trigger them enough, they will get engaged and start to be developed. This is a picture of a muscle fiber. It contains of myofibrils as a smaller particle, and in there we have two parts, actin and myosin. Those are the proteins that really make the contraction in a muscle. And our next picture is going to show you a little bit that more in detail. It's very schematic, but you can see the top picture is when they relaxed, and then when those proteins come together, you get your contraction. What you need for that contraction is energy, and in most cases that will be supplied by sugar. When we start training a horse, what you get with that is that more active cells become active, so we have a more active tissue. We also get that those cells get the muscles get better oxygenation. And this picture shows you that. The left, small blood vessels, and at the right, more bigger vessels after training. The energy that we need is quite often in the form of sugar. Also fatty acids can be used. And we have two ways of using that energy. One is them with oxygen, what's called aerobic. And then we have another way when there is no oxygen available anymore, what's called anaerobic metabolism, and that produces lactic acid. That's really important because the lactic acid is really going to trigger things. The aerobic metabolism is very efficient. The anaerobic is less efficient, and it produces this lactic acid, what triggers the muscle. Here we'll see a graph, and what you could see those two curves. The left curve is from an unfit horse. The right one is a fit horse. So what you could see is that when you look at the left, the axis is the lactate, the concentration of lactic acid, and on the bottom is the velocity. It's like the work. So what you will see is the more work, the higher your lactic acid. And if you have 4 millimoles or less, then the lactic acid is not effective in stimulant. If it's between 5 and 10, it will be very effective in stimulating new muscle development. And when you go above the 20, you get damage. And if you remember that shape of the graph, it quickly goes up, so they're very close together. And when the energy is not available anymore, you will have no contraction. When you have no contraction, you have no protection. Muscles can no longer protect joints and ligaments by contracting. They're certainly less capable of putting force on those ligaments and tendons, and that's when you get the damage. We have three types of contraction: concentric, when the muscle gets shorter; isometric, when it's the same size; and eccentric, when the muscle gets shorter. Look here, this is the concentric. The muscle gets bigger while it gets shorter. Then we get the middle position, isometric. You see the muscle move, but doesn't get shorter, doesn't get longer. And the last one is when the arm gets longer, so the muscle gets longer while it needs to bring energy. It's called eccentric. This shows that again. The top, concentric, when you lift a bottle, lift something. Then after that, the eccentric, when the arm goes down. And in the lower portion, the isometric. When you look at that in a horse, when we talk about concentric, that's really acceleration or steady state, you go. Isometric is postural exercises, keeping your head in one position. And eccentric is really when we talk about collection and deceleration. And the more collection and the more of an uphill frame we want to get in the horse, the more of that eccentric contraction. There are two types of muscle fiber. Type 1 is the fast twitch, but quickly can contract, but quite often it gets quickly tired. And we have the type 2, what can do contraction much longer, but it's quite often not as powerful, but can keep up doing that. Like type 1 is really like powerlifting. Type 2 is more like endurance. And every horse has a certain amount of those fiber types, and they're genetically determined. When you train muscles to that, you can train them for endurance, or you can train them for the power. And both training types give you a really different way of stimulating your muscles. For endurance training, trot is the best gait. You can do circle in, shoulder in, walk, SuspLig exercises, and walk and trot stretching exercises. More or less same frame, same gait. This would really triggers the endurance, so let's say the slow twitch fibers. So if you want to make a hind leg quicker, then these kind of exercises are not really the ones to do that. When we talk about power building, that are really energy explosions like extension and collection. Uphill work is really a good one. Transitions between the gaits or in the gait. They have to be short time and fast. You need to give some relaxation periods in between and some stretching. Those exercises really going to focus on the type 1, the fast twitch fibers, what we really need in dressage quite a lot. When we're talking about tendon injury, a tendon is elastic. When you overstretch it, it will damage. Quite often the initial damage is small, but by doing it over and over and over again, we get a repetitive damage, and then we get real problems. In the dressage horse, the injury, first most important injury is the suspensory ligament in the front because of extension. Here we see a picture of an extended trot. Look at the hind limb, the hind left front and the right hind. They're perfectly parallel. That's how it should be. In this horse we see a very active hind leg. It's nearly more forward than the front. That hind leg is more susceptible for hind limb suspensory problems, while this horse, with much more stretching in the front and not coming through from behind, has more chance of getting a problem in the front. The muscles keep tendons spring loaded. So when the muscle gets fatigued, then that spring loading is gone, and then the tendon gets more load. When you look here at this muscle picture, you can see all the muscles are up. Below the knee, below the hock, there is none. This schematic picture shows you that a little bit more. It's the lower front limb, and what we're going to see here in blue is the suspensory ligament. It attaches at the cannon bone, and on the other side it attaches to the sesame bone. Now in yellow is the superficial flexor tendon that's attaching to the pastern region. And now we get in purple the deep digital flexor tendon that attaches all down to the coffin bone and goes over the navicular region. Those tendons really have a muscle belly up higher up. That keeps those two superficial and deep digital flexor tendon really tense, meaning if those muscles can't keep up with that force anymore, then certainly more force is going to put on the suspensory ligament, and that's why it's so prone to injuries. What we see up here is a more real picture. Again, in yellow is here the suspensory ligament, and we get another nice picture showing you a little bit more a real anatomical picture here in white, called interosseous, but it's the same as suspensory ligament. When we talk about training, don't overdo it. When an exercise is not good, for instance, you do a shoulder in, doesn't really work, repeat it 2 or 3 times. Then when it doesn't get better, change your condition. For the shoulder in, maybe think about lateral flexion on the circle, and then start going back to the exercise. So don't overdo, because that's going to tire out muscles. When we think about a training session, you really want to do a warm-up, your actual work, lower intensity first, then higher intensity, and then I would slow down with some easier exercises, stretching and relaxation, and really have a nice cool down, what could be in walk and trot. Why this kind of build-up? Well, it's really important that when you start with stronger work, you get some more lactic acid, that it can be flushed out too. What you see here are 3 lines. The straight line in stance tells you that it takes a long time, 70 minutes, to get rid of lactic acid. When you look at the walk, it's quicker, and when you look at the trot, it's even faster when it removes. So when you do some workouts, some cooling down with your horse, walk and trot is much better to do than just done and put the horse back in its stall. With this training session, you really want to stress the stretching to reduce spasm and improve perfusion in the muscle, and you can do some breathing exercises to give the horse some time to deep sigh and get his breathing back, especially when he got stressed. You want to have your short, brief moments of relaxation, really walking on a long rein or trotting on a long rein, and maybe even cantering on the longer rein. And you have short, brief moments of intense excitement. Really make them, wow, quite excited for. When we think about how we do our training session, we start relaxed. Then you get a higher intensity load in the first half of the session because there's still a lot of muscle power there. You do some variation of your exercises, and not too long in the same frame in the same gait, because the changes give quite often when you stretch a little bit, give some options for the muscle to get better blood supply. And you build conditions for your exercises, and when the exercise is not good, you try to improve those conditions first. And think about it, the curve of excitement. When he's constantly stressed, you don't do too much. Really important to realize, training muscles, when your intensity of work is too low, they're not effective. When it's too high, then you get damage. And you have seen there's a small margin in between those. That means that it's tricky and you need help, like a trainer, your vet, something like that. Thank you for watching.